All right, in this lesson we're going to go over the configuration steps in order to test ATM, specifically using TT cell 1. The first thing you want to do is we're going to use terminating connection of an OC3. We're going to test ATM, and we're going to use quality of service statistics to give us the feedback. All right, obviously this requires that you be connected to an ATM device optically, and I already have a circuit configured to test. So we're going to go ahead and assume that's been done and show you the steps. Of course, first thing you do is set up the test that you're going to be doing. The type is going to be ATM. The timing we're going to use is internal. We're going to terminate the receive input. Beep on air as is going to be off. Alarms will be path AIS for sonnet. We're not going to be dealing with this because the sonnet framing is going to be done for us. We're not testing that. Pointer is not something we're going to deal with here. Trace, this is the byte that is going to be used in the sonnet framing to test whether or not it's working. Basically, you put in a sentence. This is a pretty standard test. Quick brown fox, and you can put anything you want on there. You're just using that to see if the data comes back. This is what we're going to use for the section test of the sonnet framing. Again, you can put anything in here. It doesn't matter. Overhead. This is used in the sonnet framing. We're not testing sonnet framing, but we can show you a little bit of how that works. We're not going to be using APS that deals again with sonnet. Here is what is important. This is the bandwidth or the data rate that you're going to be pushing out of the device. If you're familiar with ATM circuits, you know constant bit rate and variable bit rate, and we're going to be dealing with kilobits per second as opposed to a percentage of the OC port or cells per second. Continuous bandwidth is going to be, we're going to test the T1. So there we go. Correlation tag leave as default. We're only using the primary profile, so don't worry about the secondary transmit profile. We're going to be using, like I said, the TTC1 type cell. You can choose between any of them. There's differences in the bytes themselves. It doesn't really affect us too much for this test. We just want to see the test cells come back. Here's the important part. Primary profile 1. You can program up to 4. We're going to use profile 1. And you can see here you have a slot for VPI and a slot for BCI. What we're going to do is we're going to select 0 and then 100 as the VCI. You can change the cell type here from uni to NNI. This isn't important for us in normal tests like we're going to do. If you get deeper into more complex things, you would use uni and NNI to test network elements and non-network elements. We're going to keep scramble on, and the wavelength, you can choose either one. It's not really a big deal. We're going to go ahead and use 1550 and hit OK. And of course, in order to make the test actually work, you actually have to turn the laser on. And you can see here from this main screen that we get 2 screens, all summary results OK. Now, if you're used to dealing with serial connections and you use these type of devices, you're going to think automatically that this is the test and it's good. But there's actually a lot more to it. We're going to separate the screens. The first one's going to show sonnet and summary. We get signal losses because this is actually, it's just started. We'll go ahead and restart it, and you'll see those will clear up. Now under Sonnet signal, you can see the receive frequency, and also a really neat thing is you can see the receive level power in reference to dBm. As I showed you with the system setup, you can test Sonnet framing using path and section, and you see there's the text that was already entered. Test section, again you see the Sonnet framing's good. We're in loop and we're getting it back. Now we're looking for an ATM in order to prove the path. We're looking for that same TTC1 cell to come back to us. You hit cell type and you see there TTC1 is lit green. That means all the TTC1 type cells that are being transmitted, they're all coming straight back. You can reference it like a pattern in serial communications. Another thing you can do here is look at the quality of service, and that's kind of a big thing that tests whether or not it's actually providing good service. You can see here the minimum delay variation in milliseconds, average, and the amount of lost cells. As you can see, there's no lost cells, no misinserted, no problems with it. You can show errors here. Of course, there's none because we have a good test setup. You can show time. You can show statistics, the utilization of the OC3 port as a whole. And of course, we're only using like 1 meg, so we're only using a small percentage of it. It'll show you here, again, your VPI, VCI. It'll show you the amount of cells, total congestion, and that correlation tag. So you can do injection of errors, frame errors, and AIS. That deals more with Sonnet, as you can see there. And it also has, it'll give you errors on ATM. But like I said, we're not, for this purpose, we're not going to be really discussing Sonnet, just kind of showing you it's there. Let's go back to the cell type and show you changing the cells to a different test cell. You can see now we're getting a TTC4 cell back. And the O.191. If you really want to test the capabilities of the port, you can of course increase the amount of cells that you're putting out. We can go ahead and do that here. You can do percentage and show 100% of the bandwidth. So now it's going to be actually using the entire bandwidth, so an entire OC3. And now you can really test the network and see how well it performs under stress. Let's see. You see we're getting the test cells back, and now again you can see the minimum delay, the average, and again no aired cells. Under statistics again, you can see it's slowly showing higher and higher utilization. Eventually it'll get up to 100%. And you can see the the congestion is 0. So the ATM circuit that we have here is configured and running smooth. So no problems. If you have any questions, like always, read the manual. If there's anything that you missed here, just take a look, and that'll answer the rest of your questions.